Hello, good morning, everyone. Today I'm going to discuss about self-organization maps. Uh, Actually, this self-organization map is an unsupervised machine learning algorithm, and it classifies data without supervision. And this self-organization map is not series of layers, and instead of 2D grid of neurons. And this some doesn't learn through error correctly like artificial neural networks, but it implements something called competitive learning. So I here build a self-organizing map model to uh, check the dataset, cancer, breast cancer dataset that available in the net. First of all, I mounted the uh, my drive to the caller to get access the data file that I modified. In that data file, there are some null values, and so I have to replace it with zeros. Then I imported the Panda libraries to handle this dataset. Uh, then through this code snippet, we imported the data file .csv that contains the data breast cancer dataset, and then set the values of data file to the data variable using the iloc function. There are three inputs for the dimensions, and then we call the class function summer give with the relevant parameters and data for the created data set and other functions that call in this class function. And let's go to the summer class function. Here we have the class summer function. uh, First we initialize the uh, initialize function. In there we call data and other required parameters. Then we define the coordinates for the normalization. We need to normalize our data set as later we have to calculate Euclidean distance uh, and extreme values in the data set. And for the training part, we have three steps. First, we have to select a random input vector. And the second step is calculate Euclidean distance between selected input vector and vectors of the grid. And then third step is the we have to move the BMU and its to the neighborhood according to the radius near to the input vector. To this purposes, training, first we have to find the BMU. So we code the code set for the code function for the finding the BMU value. And here we have three functions called, and from these three functions, decay, learning rate, decay radius, and influence functions. Through these steps, learning rate and radius decrease according the with these functions. And after that, this is the training function for the self-organization map. And after we done the training, we can visualize the result using this plot sum function. Uh, After setting up the summer class function, we call normalize and train another function in the one by one to visualize the data sets into the 2D grid plane. First, we call the normalize function and the train function, and after that, we after train function call, we plot the visualization. We can see how that data set visualized in this plot into 25 grid, and we have 4,000 iterations for I have taken 4,000 iterations for this grid. Mm, we can see how those data points are into this 2D grid plane for this self-organization model. uh, when we consider how the weights in some self-organization maps algorithm change with these input vectors. Uh, First, we identify what is this uh, weights in what is this weights in conventional self-organization maps, and the weights of the winner and its neighboring neurons are updated regardless of their distance from the input vector. The weights within the neighborhood updated tells that the new updated weight for the node ij is equal to the sum of all weight and a fraction of the difference between the all weight and input vector. In other words, the weight vector is moved closer in towards the input vector. And the important element to note is that the updated weight will be proportional to the 2D distance between the nodes in the neighborhood radius and BMU. You can see when we change this input variables, uh, wait, and we train the model and check the load. That's different than the how changing the self-organization maps. The points are gathered to their 11 places. And thank you.